Please stay tuned, okay? Stay connected, please. So, if I am talking about the problem, then of course, such problems have some solution. Am I right?
Yes, sir.
So, whenever you need some solution of a
System.
so you in your intermediate or A level class, whenever you are solving the Cramer rules, you are set the solution set.
Yes, sir.
SS. So solution set is basically what? The solution of
Possible
the
solution.
possible problem. Okay? Brilliant. So this problem come from equations. And in this equation or technically problem is what? State-based models. State-based models. Model is kind of a set of an equation. Set of an
Equation.
this is thing is clear?
Yes, sir.
You made some kind of some yes please question? No. If you told me in the state-based model, what is the theme? Theme is this: you need to reduce the error between the target and the your observed thing, your wanted thing. Someone have assignment?
Yes, sir, you gave us.
Yeah, this is the state-based. Yeah, let me check out what few people wrote and what is. Okay, definition. She wrote the when we analyze multiple inputs and multiple outputs using space analysis, output equation and state equation collectively non-state models, I should suicide. Yeah, actually once you should know what is going on, okay? That's okay. That's okay. Okay. Someone else can give me the
State space analysis.
okay,
State space analysis.
Sir, copy this also. Set space analysis.
yeah, that's okay. Okay, please. It allows state and search space model. What is it allows for a formal definition of a problem as per the need. As per the need to convert some given situation into some desired situation. Given situation, desired situation. Thank you so much. What is your nice name? Numan. Okay, my daughter, don't worry. You are also okay. Task printed. So, yeah, desired, okay, situation and the given. What you want to do? You want to equalize. That this one is the given. Your desired is not the exact. For example, 4 GPA. 4 GPA is kind of a given for. If you want to get 4 GPA, you need to get 100 out of 100, or you can say get maximum score for 4 GPA given. But your desired is 4, but
Given is 2.1.
no, given is 4, desired is also 4, but desired depend upon your efforts. It is not exactly 4. Desired is not exactly 4. Some students are brilliant, some students are, okay, do not even, no one is a dull student, okay, remember one thing. No one is a dull student. You all are brilliant. The important thing, you need to work hard, struggle hard. This is the one thing. So, you want to equalize both of them. Desired, you want to improve yourself in order to achieve the given target. Given is kind of a target, desired is some kind of a wanted. Whatever you want, you need to make it maximum in order to reach the target. This is the one thing. However, if there is a difference, for example, you are saying your desired is representing with y and you are given, okay, so this is the y, or sometimes you can say that parameter y sub theta, okay, whatsoever, depend upon the weight parameter, and given is some kind of a benchmark thing, it is somehow y. what technically you want to do? You want to minimize the difference. You know, it's very simple for you to get 2 out of 4. But for getting 4 out of 4, you need to reduce the difference. So this difference basically is what? Kind of an error. Kind of an
Error.
And this error between the benchmark is a given, and between your desired.
Yes, sir.
This is the error. If you want to reduce the error, what you need to do?
Work hard.
Huh?
Work hard.
Sorry?
Work hard.
Work hard. But in terms of AI, what you need to do?
Accuracy.
Accuracy. But what you need to take a huh? Sorry?
We'll have to search.
Search.
Analyze data.
Model.
Analyze data.
More data.
Best sequence.
Remember, please. Your teacher really would like to suicide if you do not grab the basic idea you studied in your primary school, middle school, OA level, intermediate, secondary school. This is the kind of, you need to take the scale. Now you say, sir, you are stupid. Yeah, sir, teacher would like to tell you something. You need to take this scale. Yeah, George Trevor. Okay, go. I will go there. A minus B. Of course, you studied A minus B. You need to know how to interpret A minus B. So this scale is known as least error scale. So
Yes, sir.
how it is related to minimize the error? How it is related to minimize the error? So my child said that consider this is somehow scale. A, length and width both are same. Area of a scale. This is known as a scale. Now if we want to reduce, error with some kind of a benchmark error kind of a thing. So you say this one is some kind of a, this is your A scale is a kind of a given, and this one is your B, okay? So you can say that if I say this length into width, okay, this is the small arrow, this one the small scale, this one is the small scale, and this one of course length and width both, and this one is the B scale. This is in big box, your aptitude, your ability, B scale, but you need to expand it, or you need to reduce the bigger one, A, okay? So you need to minimize the error in computer language in AI system. So how, my children, see, if I consider the width, this one is the width, of course here. So what will be the area of this green part?
A cross B.
A cross B, brilliant. This will
Yes, you have minus.
A into B. A into B. This is the area of the green part. So if I want to say this, because you know what is this is the width, this is the height. So I said the height here, yeah, B. If I say like this, then are you getting my point? And this I will consider, okay? So because here I also go upstairs, but here. So what will be the area of this pink, purple color? Okay, remember this A is complete length. If I subtract B from this A, then this one,
B into A minus B.
this one basically it will become A minus B. Now of course this one is the A minus
B.
B. And of course this one is the big A, B is subtracted away, then this is again what?
A minus B.
A minus B. So my children, this is the A minus B, this is the A minus B, length into width, this is the yellow part, so A minus B
whole square.
whole square.
Yes.
A minus B whole square. You can notice big A, white A scale is a big one. Now you reduce, you minimize the scale. and this one is the a minus b whole square. If I say, you have some question? Do you want
A minus B सही समझ गए.
a minus b?
समझ नहीं.
Okay. This one is the a is the white is the complete length.
Yes sir.
Yes.
This side again complete length.
Yes. Sir.
Okay. Here I said that subtract away the b. From where? A. For example, a is equivalent to 10 and b is equivalent to 2. 10 minus 2 will be 8. So here a minus b represent 8.
Sir, B इसमें rectangle है या square type?
Here, is it okay? This is the 10 into 10.
Okay sir.
You want to deduct the, somehow, both side length into width. So this one, this is what? It's the length, 2. And throughout the square you will cut. Am I right?
Yes.
So again, this side you cut the 2. You will not, this, you already cut it down.
Yes.
But here, this is the only portion left.
Yes. Sir.
So, are you getting the point?
Yes. Sir. Now.
Now, then it's this part will become, you will multiply 8 into, 2. This one is the somehow 8 into 8.
Yes, sir.
Are you getting my point? And this one is representing, this one is the 10 and 10 into 2.
Yes.
So, my children, you can see this is the 8, this is the 10 into 2, and this one is the
2 square.
2 square, and here is 2 square where, my children? This corner. Are you getting the point?
Yes. Sir.
So, this one is the big one,
10
A
into
square.
10.
Now you can see, what is your nice name? My this check shirt? Heather, my child, this is AB. Okay? Now see, this is the A minus B, big square. Big square is what? A square
Plus 2AB.
what you will do from this big A square, you want to minimize, then you will subtract away the minus
2A.
minus AB, minus AB, remember here, this one. So here.
Sir, formula sir.
Yeah, this one. This AB, just please. Now here, this part, this purple part, B into A minus B.
Yes sir.
Please. So we will also subtract away from this big AA white color part, okay? This big box. So minus B into A minus B. This is the A scale, this is the plus. Remember this one is the
Plus.
plus. We will subtract away AB. Another part, this one, then let's go. A square minus AB minus minus plus B square. So A square minus 2AB plus B square. So from our childhood, we are this square means we are minimizing the big error to the smaller one. Are you getting the point? Yes, so in terms of linear regression, first so it's a linear algebra. You got that in the AI linear algebra is using.
Yes.
But unfortunately, our people don't damn care about this. They just tell the story, this is. No, my children, this. So you need to reduce the basically gap, error. Okay? And this error is like this. This is clear?
Yes,
Let's
sir.
go to the second thing. Second thing is also very much important. Least square error. In this least square error, there is some term which is known as linear regression. So remember this least, this one is look like this, okay? Never forget. In some books, textbook notation, it is also given like this: y minus y norms. Technically, meaning is same. Meaning is same. Are you getting my point?
Yes, sir.
Yeah, never be confused. So what is the linear regression? linear regression concept is again very beautiful. Let's see if some farmer growing up some vegetables and fruits in his fields. So of course there is some, once fruit or vegetables become ready, he want to sell it out in the field. If he said that if someone come and pick that fruit or the vegetable from the in my field, then price will be at, this is the zero position. No distance covered by the farmer
To market.
in order to place or ship the fruits or vegetables to the big market. In his field, for example, in case of some fruit, apple, 10 rupee, 10 PKR per 1 kilogram of apple. This is the price. This is the price, price bar. And this is somehow distance,
Yes.
x. This one is the y. Y is representing some price, this is the x. My children, very beautiful concept over here. So at this point of origin, no movement, price is 10. However, if I move from point A to B, my distance
Price
from
will be-
origin to destination, then
The price
in
will
my case, my distance will, if I talk about the distance, no price, then distance will become zero. But in case of a price, it is something else. Farmer said that this is the benchmark thing I will charge. In case of fertilizer using, in case of machinery using, my hard work, 10 rupee per kilogram he will charge. So this 10 rupee, of course, this is the point A against, this is, you can say in case of point XY and at some another point B. This is one point, this is point A. Another point B here, after covering some distance, and you can say distance is the 10, this is the 0, this is the 0, 10. At distance 0, price is 10. If the distance 10 kilometer, this is the x-axis distance.
Okay.
So at distance 10, price become 100.
Yes.
My children, at this point, equation of a line, because like straight, are you getting my point?
Yes, sir.
Follow some equation of line, and this I apologize for this. I need to report some. Thank you. Okay, we are considering some equation of line y mx plus c. My children, what's the c basically?
Constant.
Huh? What's the constant basically? Huh? Error. No, what's the constant? 10 rupee. Yes. Very well done, excellent. Let me follow that. So remember, it's the thing which is kind of an intercept. This is known as intercept. Y
Intercept.
this is the farmer choice. This is the farmer defined thing. You cannot, that's why it is known as a constant. It is a constant. It does not affect about the distance covering. So it is for example, I start my business with my empty pocket, 0 rupee in my, so in this case, intercept value, 0. Zero. Remember,
Yes, sir.
Maybe after 10 years, I become the billionaire or millionaire, or nothing. So the intercept value 0. Start the business from the empty pocket. But farmer said in case of price, once vegetable come ready, the 10. So 10 is in this case intercept value. Now another thing is some kind of a slope, rise over run. You can say that the distance covered, y2 minus y origin, so x2 minus x origin. So this is the x, so this is the y, x1, y1 whatsoever. This is equation of line. So in this case, my children, we know this is the point of origin in the farmer field. This is the Islamabad capital, okay, vegetable market. But what will happen? How AI work?
Predict.
And somehow predict
The prices.
prices somewhere in the middle. For example, Tesla vacant, not defined. No, then you will see the distance. Okay, you know the intercept value. You know intercept value, but you also know the slope rise over run. Okay,
Yes, sir.
distance over cover. Okay, whatsoever. So my children, whatsoever the value, then you will get the. Are you getting my point?
Yes, sir.
So this is known as a linear regression. Remember, okay, very important this concept in AI. Two things. What we learned two things today: least square error and the linear regression. How more basically what happened? Linear regression. What happened? Linear kind of a line, because I was talking about some concept of line. This is concept of a line. My children, but remember, okay, for example, some child, there is a, okay, at the age of 1 child weight it should be look like this, at the age of 2 child weight should be look like this, but these things can be noticed in the books, but in practical some, okay, at the age of 1 to 10 weight of all the persons are not go through the follow the line. Some becomes, okay, get more fat at the age of 10, some become skinny, okay. So things are look like this along the line with the passage of time. So what is this basically?
Error.
Yeah, this is the error.
Yes, sir. Mean square error. Yes.
Yeah, mean square error, you can say. So all are these what? Scales. These are scales. Technically, for example, I am visiting to doctor and doctor said, what is your age? I said this, what is, okay, maybe in old age, of course, thing, but in the growing up age. So what is your weight? I said this. Doctor said, no. At this age, your weight and your body mass index, okay, your height should be like this. Then, because we follow some kind of a line, equation of line. So what I will do, I will try to reduce this big scale to reduce the smaller one with the help of least square error. A minus B whole scale formula here. So reduce the big scale into the smaller one, into the smaller one, into the smaller one, into smaller one. So reach near to the line. This is the concept.